So what I'll do is I'll just give you a quick review of last session. So we have seen the IP addressing, where we have seen the three classes A, B, C, and for each class, which there are 4 octets of each IP address. So which part is network part and which part is the host part, that we have seen with the example of a building, floor ID, and flat number. And we have seen the range of each class. So what is the range and why this range? Is this one 1 to 127? What are these fixed bits and all these things? Then we have solved few problems based on the discussion that we have done. We have also seen what is the subnet mask. So I'll repeat the concept of the subnet mask, that we need a subnet mask for identifying what is the network from the IP address. Okay, so what we are doing is we are masking the host bits. So in class A, what happens is, as there are 4 octets, only first octet is a network section, and all 3 other octets are the host section. Okay, so number of network bits are 8, that is first 8 bits. So only we want those 8 bits, and we are masking all host bits. So all host bits are 0 and all network bits are 1. So that value becomes the subnet mask. And when you AND this data with any class A IP address, you will get the network address. That example we have seen in the last session. Similarly, this is the subnet mask for class B, and this is the subnet mask for class C. Okay. And these are the network bits for class A, class B, and class C that we have seen last time. Now we'll see the new concept, that is private IP addresses. Okay, so as you know, every one of us, we are using internet at our home, and most of us are getting this IP address 192.168 something dot something. Okay, so if you just execute the command ipconfig command on your machines, you'll get the IP address, and most of you are getting the same IP address. Now, one question comes into mind, that what is an IP address? It is a unique IP address for in the network, right? But how come most of us are getting the same IP address? Okay, so the answer behind this lies in this slide. There is a concept called as public IP address and private IP address. What happens is, let's say if I type what is my IP? Okay, I'm just googling what is my IP. So I'm getting some IP address. You also can do this on your laptops or browser. You'll get some IP address. Okay, now that IP address will be unique on the internet, in the world. Okay, and that is because it is a public IP address. Okay, but when I type ipconfig, so I'm just typing the command ipconfig. So I'm getting some different IP address here. I'm not getting this IP address 103.96.41. Okay, and anywhere you will not see this IP address. Okay, so it will be seen as 10.0. something. Okay, or 192.168 something. Okay, so This is the difference between the IP address. This is called as private IP address, which is configured on my private network, and this is my public IP address, which is known to outside world. Okay, so now why do you need this? Okay, so let me give you the idea. Okay, now consider this is your home, this is your friend's home, okay, and this is someone else's home, right? Everywhere you're getting some fiber optics cable. Okay, it might be Idea, it might be Airtel, it might be Geo or BSNL. So you're getting the internet connection through some cable at your home. Okay, now each one machine should be getting the internet through one fiber optics cable. Okay, so that is the case at every house. Okay, some of the houses might have only two devices which are using internet. Some of the houses might have more devices. Okay, what happens is whatever connection you are getting from the internet service provider, okay, that internet service provider cannot provide the separate IP for each and every machine, because IP address is a size of the IP address. What is the size of the IP address? Anyone?
32-bit.
Yeah, it is 32-bit. So maximum hypothetical maximum IP addresses that you can have is 2 to 32. Now think of the number of machines in the world. We are talking about the internet, so we have to talk about all the machines which are on the internet. Okay, if you are providing the IP address to each and every device, then you'll fall short of the IP address. Okay, because the devices in the world on the internet definitely will be, multiples of 2 to 32. Okay, so what happens is the ISP, that is Internet Service Provider, gives you only one IP, which is called as public IP. Okay, through which you are accessible over the internet. Okay, but how will you get the internet for all the machines which are there in your house? Okay, for that you have to configure different IP addresses. You have to create a private LAN, okay, and give the private IP addresses in this private LAN. Okay, so one IP which is public, which is provided by the internet service provider, okay, for the whole complete network. Okay, and inside the house or inside the organization, every organization uses the same concept. Okay, even if you consider biggest player, IBM, Accenture, or any organization. Now, for example, MIT World Peace University has at least 25,000 desktops and laptops at any given moment of time on the internet. But you don't have 25,000 connections. Okay, so all you do is you configure the private LAN, which will use private IP address. Okay, and you'll use only one internet line, which will have 100 Gbps line or 1000 Gbps line, something like that. Okay, one line, which will be then distributed to all the private network. Okay, so you'll get one public IP and one private IP. Now, the public IP that you get, okay, here, it will be the same public IP you'll get on all the private machines. Okay, so if you ask your family members to find out what is my IP, then everyone will get the same IP because you are getting the internet from the same IP, right? But everyone's this IP will be different because it is local network that you are creating. Okay, this IP will be different for your own network, but this can be repeated in all the private networks. Now, if you just see here, the same IP addressing scheme which is configured over here, it can be repeated here also because it is completely private in this. Now, for this one, another public IP will be there. It will be completely different. Okay, even if you are getting the internet from the same service provider, let's say Idea, but public IP will be different for this one, and private IP addressing scheme can be same in this network. So private IP addresses can be repeated in each private network, okay, and public IP will be same for all the machines here, okay. So this is what the concept of public address and private address. Okay, so what are the private addresses in each class? Which are the available private addresses? In class A, this is the range. This is the 10.0.0 that you can use for the private addressing. For class B, you can use 172.16. This is the range of private addresses. In class C, 192.168.0.0 to 192.168.251. So any IP address range you can use for the private IP addressing in this table. Now I would like to have questions from you. Have you understood the concept? Public IP address and private IP address?
So, for every private IP address, we can have about 2 to the power 32 different machines connected to it.
32 different machines. Sorry, can you please repeat?
So for every private IP address, we can have up to 2 to the power 32 different machines connected on
No,
the
no, no,
same.
no, no. It depends on, see, in this case, let's say in class A, you have the IP addressing scheme as, let's say, 10.0.0.0. Okay, so this scheme you are using. So how many machines you can have? It depends on number of network bits and number of host bits. What is the scheme of class A? It has 8 network bits and remaining 24 host bits. So how many number of machines or how many number of private IP addresses you have? It is 2 raised to number of host bits. That is 2 raised to 24. This is the hypothetical number. It is not 2 raised to 32.
Yes, sir. Got that.
Okay. Any other question? Okay. So we'll move ahead. Now the next concept is subnetting. Okay. I hope you have gone through the YouTube video that I've shared with you. You might have understood the concept or you might not have understood the concept, but at least if you have gone through the video, you'll come to know very easily what is subnetting, what I'm going to explain you right now. So here the concept is, let's say we have a one network. Okay, now consider how many machines you can have in one network. That is 2 raised to 24 approximately. Okay, in one network. But what if I don't need 2 raised to 24? I need only 2 raised to 21 IP addresses. What will happen is the rest of the IP addresses are wasted. Okay, so let's say, let's take the example of 192.168, let's say 10.0. This is one network. Can you tell me what is the class here?
C.
It is a C class. Okay, in C class, first 3 octets are the network bits, right? And 1 octet is a host bit. That means how many number of hosts you can have? 2 raised to
2 to the power 8.
correct,
8.
approximately, not exactly, but approximately. Now 2 raised to 8 is what? 255, right? So that means in one network I can have 255 IP addresses. Now, if in my local area network I need only 3 IP addresses. So whatever the IP address I'm using here, with this, how many IP addresses are wasted? 252 IP addresses are wasted, because I cannot use these IP addresses, remaining IP addresses, anywhere in the other network. Okay, so that is one reason we have to save IP addresses for different use. Okay, so that is the problem of this IP addressing scheme, class A, class B, class C. Okay, so if we go back to this scheme. So in class A you have some scheme, you have in class B you have some scheme, in class C you have some scheme. So if you follow the class A, B, C scheme, you'll have, you know, fixed number of network bits and fixed number of host bits. Here in class A, you have fixed number of host bits. So these many IP addresses will be generated automatically. But what if you don't need 2 raised to 24 IP addresses? Okay, so for this reason, we have to change the scheme. So the basic scheme is called as classful IP addressing. Where you can give the example of class A, class B, and class C. Okay, there is a concept of classless. Okay, which is called as subnetting. It is also called as variable length subnet mask. Okay, or it is also called as CIDR. Okay, which is classless inter-domain routing. Okay, so all these concepts are the same concept. Okay, now I'll tell you what are these concepts, right? So basically what you have to do is, whatever the networking scheme you have, okay, you can create the number of subnets, okay, by changing the scheme. Basic scheme is what? The class A scheme is network bits and host bits. How many network bits? Class A 8, host bits 24. Class B 16, 16. Class C 24 and 8. This is class full. In classless, what you do is you change this scheme as per your need. Okay, that means if I need only 3 IP addresses, I'll find out how many number of host bits I'll require, and depending on that, I'll choose the network, number of host bits. Okay. Or in one network, how many number of subnets I want to create, that I will have to find out. Okay. So that is the calculation that you have to perform. So I'll give you, I hope now you have pen and paper, because we are going to solve few examples here. Okay. Give you the idea first. So let's say 192.168.1.0. This is the IP address I have got. So obviously this is class C, where first 24 are network bits and these are 8 host bits. Okay. Now here, how many hosts are possible? It is 255 number of hosts. So that is 2 raised to h equal to 255. Now I have also given you the concept of network address and broadcast address. What is the network address? Network address is the one where all host bits are 0. If you refer my last session, that is the network address, and network address is this one, 192.168.1.0, because all the host bits are 0. Okay. And the broadcast address is when all the host bits are 1.
255.
Yeah,
255,
and that is
right?
255. So broadcast address for this network will become 192.168.1.255. Correct. So out of 2 raised to h number of host bits, the 2 IP addresses are gone. Okay, so actual number of IP addresses that you have is 2 raised to h minus 2. Okay, in class C or class A or class B, what you have to do, I'm sorry, when you want to find out the number of actual hosts that can be addressed, it has to be 2 raised to h minus 2. And what is h? All the number of host bits, right? Now, if I want to assign only 5 IP addresses, I don't need 250 IP addresses. Okay, what I need is only 5 IP addresses. So how many bits I need in the host part? Minimum bits. If I take only 1 bit as a host, 2 raised to 1 is only 2. Out of which I'll have to subtract 2 IP addresses, because 1 for the network address, 1 for the broadcast address. So this scheme is not possible to assign any IP address. Consider the value of h is 2. That means only 2 bits are therefore, instead of 8 bits, only 2 bits are host bits. So in that case, 2 raised to 2, that is 4 minus 2. So only 2 IP addresses I can create using 2 bits. Okay. So this is also not possible because I need 5, at least 5 IP addresses. For 3, 8 minus 2, I'm getting 6. So this is suitable. I'm getting 6 IP addresses with how many bits? 3 bits. Okay. So instead of 8 bits, I will use only 3 bits for host. Okay, so I'm changing the basic rule of 24:8. So in that case, what will happen? The scheme will go as 24 network bits only 3 bits are host bits. And what are the remaining bits? 5, because the total has to be 32. IP address scheme is 32. 24 are network, 3 are host, and 5 remaining are subnet bits. So that is S, number of subnet bits. So in this network, okay, in this one network, how many subnets I can have? That is 2 raised to 5. That is 2 raised to S. Okay, again, there also you have to subtract 2. I'll tell you how. And how many number of hosts you can have? 2 raised to H minus 2. So this is the calculation that you have to remember. How many number of subnets you can have, how many number of hosts you can have. Okay, subnet as in small departments. Let's say I have an organization, MIT, so I'll use one scheme here. Okay, how many departments I can have? That is 2 raised to 5 minus 2. So at most I can have 30 departments, because 2 raised to 5 is 32 minus 2. That is 30. So I can divide one network, my complete MIT network, into 30 max departments. And in each department, I can have only how many machines? 6 machines. Because 2 raised to H is what? 2 raised to 3 minus 2. Okay. So this is the scheme. If you want only 6 machines per department, and how many such departments you can have? 30 departments. So this is the sample scheme that I have just discussed. Depending on the requirement, you can choose the scheme. You can choose the class A, class B, and number of subnet bits, number of host bits. Okay, because depending on the classes, you can change the number of bits, and that will have a classless scheme. Because now you are forgetting about the actual number of network bits, actual number of host bits, and all this. Okay, so total number of network bits in this scheme is 24 plus 5, that is 29. Any doubts, guys?
Sir,
yeah.
So why did you subtract 2 from this subnet?
Yeah,
like
that
2
is
to the power 5 minus.
correct. I'll tell you the answer. Now, let's say, I'll give you the figure is already here. Okay. Now, let's say I have divided this network into, let's say 1, 2. Let's say there are 4 subnets I have divided. Okay. Now, for each subnet address is different, right? Let's say I want to send a data to one particular subnet. So what I'll do is I will assign one IP address. Always remember, IP address is different and network address is different. Okay, so whenever all the host bits are 0, that becomes network address, and when all the host addresses becomes 1, it becomes broadcast address. Now let us talk about the subnet bits. When all the subnet bits are 0, okay, that means you are referring to the subnet address. Okay, and when all the subnet bits are 1, that means you are referring to all the subnets. Okay, suppose I want to give a message to all the subnets, not all the machines in the subnet, but I want to give a message to all the subnets. So what I'll have to do is I'll have to broadcast the message to all the subnets, right? So in that case, I will use all ones in the subnet part. So when all the subnet bits are 1, it becomes a broadcast address for all the subnets, for all the departments, small departments. Okay, and this is the network address for addressing the actual network. So this is the actual network. Okay, so when all the subnet bits, so again 2 addresses are reduced from actual number of subnets. This is called as 0 subnet. Okay, and this is called as all 1 subnet. Okay, now this concept is used by a manufacturer depending on your requirement. Okay, so if suppose you take a Cisco manufacturer, okay, what they do is they provide this as an optional. If you want to use these as subnets, you can switch it off. These 2 things you can switch off so that you can use these subnets also. So in that case, you don't have to reduce 2. Okay, so this is a actual answer. If you think it is not, if you have not understood this, let us try to solve one example here. Okay, and depending on the values which we get, I'll tell you what is the 0 subnet and what is the all subnet and what happens to these 2 subnets. Okay, so let us actually solve the example here. So this is what we have discussed, number of subnets and number of hosts. Okay, so we have also talked about network address and broadcast address. When all the host bits are 0, it becomes a network address. When all host bits are 1, it becomes the broadcast address. Okay, so you have to remember when all the bits are 0, this is a 1 octet. Okay, 1 octet. So when all the bits in the octet are 0, you get actual 0 value. When the first bit is 1 and all 7 bits are 0, you get this value. So this is a simple maths that you have to remember while doing the calculations. Okay, when all bits are 1, then the value is 255. Okay, this is the problem that we'll solve now. A small organization, the problem here is the small organization is given a block with the beginning address, okay, as 205. Let me just note down 205 163724. Okay, and there is a slash given 29. Okay, that means what? This 29 is the meaning of this one. What is the actual number of total bits? Total network bits. That is called as CIDR value. This is 29. That is the CIDR means what? It is a classless inter-domain routing. That is CIDR. And it is always represented by slash and number of network bits. Okay, so actually the problem is already solved because we have seen what is the 29, what is the scheme, number of subnet bits, number of host bits, we have already calculated in the example itself. So let us try to see what is asked. So this is the scheme which is given. Okay, what we have to do is we have to find out the number of subnets and hosts per subnet. Okay, that means how many number of departments that you can create and how many number of machines that you can have in each department, that we have to find out. Okay, that actually we have already found out in the example itself. What is the network ID and broadcast ID of each department or each subnet? That is very important. Okay, and what is the first and last IP of each subnet? Okay, so these are the things that we have to find out. This is a very important question. Okay, this kind of question might be asked for at least 6 to 8 marks in the exam for finding out these things. Okay, so let us try to see what you have to do. Now, you all have to create a table on a long page here. Okay, so first I'll have to find out the subnet ID. What is the subnet ID? Then what is the network address? I'm sorry, subnet address. Okay. Then what is the first IP? What is the last IP? And what is the broadcast IP? Okay, and this is how you are going to solve the example, the problem in the exam. Okay, so let's say what is the first subnet, second subnet, and so on. Okay, so what you have to find out is how many such subnets you can create using this scheme. Okay, first thing first, tell me what is the class of this example. Basic class.
C.
Anyone?
The C class.
It is a class C, right? So in class C, what is the scheme that you have? Network bits are 24, host bits are 8. Correct? What is given here? 29 host bits. Right? I'm sorry, the network bits. That means the CIDR value is 29. So number of subnet bits S is equal to CIDR minus network bits. So what is that? 29 minus 24. That is 5. Okay. Now the new host bits. What are the new host bits? These are the basic for the class C. Now we are changing the basic scheme. So as the CIDR value is 29, so number of host bits you have to calculate as 32 minus CIDR. That is 29, and it will become 3. Right? So actually, what should I have done? We should have had. Okay, we have actually calculated this here. So number of host bits are 3. Okay. And number of subnet bits are 5. Okay. So total subnets are 30 and number of host bits are 6. So answer of first section A is number of subnets and host per subnets that we have already calculated, 30 and 6. Any doubts, guys, here? So depending on the subnet bits, what you can do is number of subnets equal to 2 raised to s minus 2. That is 2 raised to 5 minus 2. That is 30. That is number of subnets. Number of hosts per subnet. What is the value of h you have got? 3. Okay. So given CIDR value, you have to subtract from the total number of IP bits. IP address bits are 32. So that becomes 3. So 2 raised to h minus 2. So that is 2 raised to 3 minus 2. That is 8 minus 2 is 6. Okay, so this is the answer of A. Now for answer of B, we need to find out this value in the table. Okay, so what is the first subnet? Okay, so let us try to write down this IP address 205.16.37. Can you give me the binary value for 24?
One one zero zero zero.
Can you tell me from the LSB?
0
0
0 0 1 1.
1 1. So these are 5 bits, right?
Yes, sir.
Yeah. So I need to pad 3 zeros because the last octet is 8 bits octet, right?
Yes, sir.
So this value is also a 24, right? Now these are all 8 bits, out of which are host bits? These are the host bits. And these are the subnet bits. Okay. So what I will do is for the first subnet, I'll keep all the subnet bits as 0. There are 5 subnet bits. I'll start with all zeros. Okay. And then all host bits also I will keep it as 0 because I'm talking about the subnet address. Okay, it is not an IP address. When I'm not talking about any IP address, all the host bits are 0. Okay, that we have already seen. Network address.
But 0 subnet is reserved, right?
Yeah. I'll tell you the reason a bit later. Okay. Let us try to find out all 32 subnet address here. Okay, 1 to 32. Okay, and then why to subtract these two, when to subtract these two, when not to subtract these two. So that I will tell you after we solve this example. So let us try to jot down all the IP addresses here, and then we'll remove these. Okay, let us start with the first one. So this is a possible value, all zeros, right? So in this case, my IP address will become as 205.16.37.0. Is it correct? Now I will repeat this again in the first IP. In the first IP, what should I change? I cannot give 0 to host address. For a valid host, this group should have some value. Okay, the minimum value that I can have is, so I'll keep as 205.16.37 as common. Okay, and I'll write the octet part as 0000. So this group, I'm keeping it as same. Okay, the subnet group. And in the host group, I'm changing the value to 001. Okay, so that becomes 37.1. Correct? Now, last IP in this network, what will be the last IP?
$31.
31. 0. So I'm not changing the subnet bits because I'm talking about the same subnet. So same subnet will have same value for all the IP addresses. Can I have last IP address as 111?
No, so 110.
It has to be 110. Okay, because if it is 111, it becomes the broadcast address. So let me write down first broadcast address that I cannot use as an IP address 205.16.37.000000111. Okay, what is this value? The complete octet value?
7.
Sorry?
7.
10.
7.
It's 7.
7. Yeah, that is correct. Right. So this value, you are putting it as a whole octet value. It is not the only this value. Okay, because this represents the complete octet. Okay, but we are only working on the host part and we are keeping the subnet as same. Okay, so when all the host bits are 1, it becomes the broadcast address. Okay, and the last IP, it has to be 1 less than this one. Okay, that is 37.6. So when you write the decimal, you have to write the complete octet value. Got the point? Any doubts here? Okay, let us move to the next subnet mask. I'm sorry, next subnet. Now 205.16.37. What is the next subnet? I will change the value of the subnet group. That will be 0001. Next subnet.
8.
When I'm talking to subnet address, it has to be zeros for all the hosts. Correct? What is this value? IP address 205.16.37.
8.
Sorry? 8. Is it correct?
Yes.
Right. So this is the next subnet address. My first subnet address is 205.16.37.0. Next subnet address 205.16.37.8. Okay. Now let us talk about the first IP in this subnet. Okay. So that is 205.16.37.0.001. Now I will have one value in host part, just like this one. Only difference is the subnet value is different here and subnet value is different here. Can you tell me what is the total value?
9.
9. That is correct. So my first IP in this network will be 205.16.37.9. What is my last IP? 0.0.0.1.1.1.0, and that will be
14.
14.
Yes.
Okay. What is the broadcast address?
15.
Sorry, 15.
Yes.
Why 15? Because 0.0.0.1.1.1.1, where this is the subnet part and this is the host part. And when all the host bits are 1, it becomes the broadcast address. Similarly, can we find out the value of the third subnet? 205.16. Now it is very simple. So if you have noticed, you start with 0. Okay. Start with 0. One IP address is the first IP address. How many numbers you are adding here? How many valid IP addresses are there? 6 valid IP addresses. So you should have the first one. You should also count this is the first valid IP. So 6 is the last IP address. So 1, 2, 3, 4, 5, 6. Next IP address is the broadcast IP address. After broadcast IP address, next IP address is the next subnet address. Next, you add 1. 9 will be the first IP address in this group. You add 5. 14 is the last IP address in this group. You add 1. 15 is the broadcast IP address for this group. So what is the next subnet here?
16.
16. First IP in this network 205.16.37.17. What is the last IP?
20.
20.
2.
22. Correct. 23 is the broadcast address, and so on. Can someone please calculate this last one? Last one and just the previous one. Last one is actually simple. 205.16.37. When it is last subnet, that means all the subnet bits are 1 and all the host bits are 0. What is that value?
244.
2 power.
248.
I need the actual value for this octet.
248, sir.
248. Okay, so 205.16.37.248 is the last network. Okay, so obviously first IP address is 249. Okay, then the last IP address will be 254, and the broadcast IP address for this subnet is 255. Okay, the first three octets are same. And similarly, find out the 31st group.
We can go reverse. Last one will be 247.
Okay, so you are going this way. 247 will be the broadcast IP address. 246 will be the last IP. What about this one?
41.
241 is the first IP, and network address will be 240. And the first three groups are common: 205.16.37. Okay, now I'm using some shortcuts here, but when you solve this example in an exam, you cannot keep this as a answer. Okay, you have to write this completely. Okay. So yeah, this is the complete scheme with the problem which is asked: network ID, broadcast ID, that we have already calculated for each one. Okay. First and last IP of each subnet, that also we have calculated. Now, obviously, when the number of subnets are 30 or 32, you don't have to write down all the 32 values. Okay. Only sample 3-4 values are sufficient. Okay, just like first 3 and last 2. Right. There's one more point remaining. I don't know if I should. What is the next session after this? Can I continue this session for another 10 minutes? Okay, any doubts in this problem? So this is the problem and this is the solution.
Sir, I had an earlier problem.
Sorry?
Sir, I had an earlier doubt that what is the difference between public IP address and network address?
Public IP address and network address. Those are completely different concepts. Network address is the one which can identify a complete network. If you, I'll just go to the first example. Right, this one. A network address will refer to the complete network. Okay, let us say I'm using a private network as 192 168.1.1 for this as an IP. Okay. For the second one, 192.168.1.2 next IP. For this one, 192.168.1.3. Okay, so these three machines are given as an address as these three. Okay. Now these three IP addresses are from which network? So this is the question. Okay. So the answer is, this is a class C network and this group is the host part. So I should make the host part as 0 and that becomes the network address. So my network address for this network is 192.168.1.0. As soon as the all host bits are 0, it becomes the network address, which identifies this network. Okay. Now it is nothing to do with the public IP address or private IP address. Okay. Now, what is public IP address? That means when you connect this network to the other networks, this network or some other network. Okay, the Airtel network or Idea network, you want the internet on your machines. That means what? You want to exchange the data between other networks and your network. Okay, so there you get the public IP address, okay, which is from this group, okay, which is from this group, because it is an IP address. It is not the subnet address.
Yes, the kind of that ISP service provider gives us that public address, and this network address depends on the network which is created.
Yeah, correct. So public IP address will be given by the service provider through which you can get the internet. So for my this thing, I am getting the internet from my service provider. Let's say my service provider is BSNL. BSNL has given me this IP address through which I'm getting the internet, or I can communicate with the outside world using this IP address. Okay, but I am configuring internal network with this scheme 192.168.56.1. This is my internal IP address. So what is the network IP address of my network using this scheme? Here itself, yeah, 192.168.56.0. So that becomes the network address. It is nothing to do with the public IP address which I have got from the internet service provider. Those are two completely different concepts.
Yeah.
Any other doubts? See, don't worry. This is not the only example that will solve. We'll solve few more examples, and I'll find out a better way to explain you. Maybe my explanation on this paper is not that great, but what I suggest you is, when I ask questions, please do answer. Please do raise your queries. If you have not understood, I can immediately answer your queries, and that way you can understand the things quicker. Okay, so